Basically, there's two key topics I really want to cover today. The first one is why open source isn't a new idea. It's a relatively new name, it's only from the 90s, but the concepts go back much further than that. We'll also look at enterprise Linux and why it's different from what you might be downloading and what you might be used to. Everybody has preconceptions and ideas of what Linux is and what Linux isn't. And enterprise Linux is relatively new, but it's not necessarily the same thing. It has a very different goal, and that's what we're going to be looking at as well today. Basically, there's too much to talk about enterprise Linux for a short seminar. I used to give talks on this that would last a week and included labs, lectures, so we can't cover everything today. So what I'm looking to do is have a short seminar that's going to give you the basics and really focus on questions and answers, hands-on labs, so that way I can focus on exactly what it is you guys want to know. So we're going to start with the basics and then we'll filter down to the specifics. A quick disclaimer, I am an ex-Red Hat consultant. My background is almost entirely in Red Hat Linux. I chose it mostly by luck. This is going back 15, 20 years ago. And for me it turned out to be the best. And it did accelerate, it did evolve, it grew into enterprise Linux. So I think I picked the right course in this case. But my focus on this is mainly because it's what I know, and it gives us a very nice evolution from standard Linux to enterprise Linux to community enterprise Linux. I'm quite happy to talk about the other distributions and what they offer and perhaps what they don't. But to avoid any confusion or start pretty much holy wars, I'm not going to cover that in the seminar, but I'm happy to discuss it. Okay, so two promises for you. I'm not going to try and sell you anything. Enterprise Linux is mostly a commercial offering. As I said, my background is mainly Red Hat. I'm going to talk a lot about Red Hat and what it can offer you, but I'm not looking to sell it to you. I'm looking to tell you about the concepts and the ideas that Red Hat Enterprise Linux brings. You may find that Red Hat Enterprise Linux is what you're looking for. In fact, if that's true, then great. You know, I know the people, I can put you in touch. If you'd rather look at something else or you have different interests, that's fine too. I'm just here to give you information and share with you my experience. You can take away anything you like. Also, as it's a fairly dry topic, I have a really awesome video to show you at the end. I'll warn you in advance, it was created by Red Hat, so it does have a hint of open source and Linux propaganda. It's not really to sell Red Hat, it's to bring Linux to the forefront. So I won't say more than that, but I'm just warning you that Red Hat didn't create this, so do bear that in mind. So a bit about me, really what qualifies me to speak to you today, what qualifies me to talk to you about enterprise Linux, and why I'm in a position to tell you why it's great, and why you should use it, and why you should depend on it. Basically what makes me an expert? Well, I hold a master's degree from the University of Liverpool in IT. I'm a chartered IT professional. It's basically equivalent to a chartered engineer or a chartered accountant. It's a UK professional qualification. I hold ICT tech qualifications and MTech qualifications through the IET. I've written some books on various open source topics, two books specifically on the CentOS, Security Enterprise Operating System, that we'll be looking at today. And so, really, what does this all hold together? A master's degree, qualifications, books, and how does this qualify me? Simple answer is they don't. I can write books, I can study for exams, I can do all these great things, but what really matters is two things. These two numbers. So anyone take a guess at what this might mean? I'll be very impressed if you get it. I'm not that. Basically, I hold 4 RHCs, Red Hat Certified Engineering Certificates. These are hands-on exams. There's no multiple choice questions. There's no correct solutions to any problems. You're given a task, the server must boot and do X. As long as you can make it do X, you'll pass that section. If you use the GUI tools, if you use the text-based tools, if you do it by hand, That's perfectly okay, as long as you solve the problem. So these are real exams. People come to these exams, they've studied Linux, they downloaded it, they've used it a couple of times, but when they sit this exam, they fail. I've seen people who have a couple of years of good experience with Linux, who have sat this exam and walked out 10 minutes in. For example, a typical example of a question, you're given a Linux box and you're told, okay, log in as root, log in as the administrator, and start your tasks. You're not given the root password. You're expected to know how the system works and how to log in yourself, how to either reset the password or otherwise get into the system. If you don't know that, then you fail at the first hurdle. You cannot progress. So you really need to know how to use the system to take that further. So I have 4 of these. The first one I earned at the age of 17. As far as I know, I'm still the youngest person to earn an ICTS. That my memory beats mine now, but at least last year when I last checked, I'm still the youngest to hold it. Okay, 14. Any takers for this one? That's the number of years that I've been working with open source. I mean actually using open source. I don't just mean occasionally seeing it on the internet or looking at it in a book. I mean actually building things with this. Web servers, internet chat servers. It's fun. That's basically half my life. So half my life I've been using these solutions to build solutions to real problems. At the age of 15, I took over the IT network from my school. I rebuilt the whole thing using Linux. It was only actually taken out at the end when I left and the person I trained left, and they couldn't find a qualified Linux person to take over. It was only meant to be temporary. We had a problem with the system at the time, and we urgently needed it fixed. We had to get exams. And the way my school did the bookings, each teacher received 1 week of time in the IT suites. The problem was, if the network was down for 1 week, that teacher would lose their entire allocation of time for the whole year. It was booked back to back solid. There was no way to get that time back. That teacher would basically lose out. We had an open day, we had parents coming in, and our network wasn't working. So we contacted Novell, they were providing support at the time. And the cost to have an engineer come out immediately and fix this problem was astronomical. Many thousands of pounds. We were a small Christian school, we didn't have this kind of money. And I said, okay, well, I can't install Novell for you, but I can install Linux. I can get you up and running, I can get things working for tonight. We can book an engineer to come back in 2 weeks when it's a normal price, when we can afford it, and we can switch back. That's the plan. That didn't actually happen. The problem was the Linux solution was too stable. It didn't crash. It never stopped printing. There were never any login problems. Teachers used to create lesson plans, assuming that the computer might work, and that they probably wouldn't. So they always had to file 2 lesson plans. With this network, they stopped doing that. And I was basically told, we cannot justify taking this out. This solution is free. It works better than the one we had before. How can we go to the senior management and ask for £20,000 to put it back to a system that gave us so many problems? We can't take that. So I've been building real things with this for 14, 15 years and doing these sort of solutions. While working for a school, especially in education, funds are extremely limited. In industry, it's often you have a 3-year renewal cycle. You buy equipment every 3 years. It's just the way things are. In schools, in education, you use what you can get your hands on. So this was a big thing for me. We would have different problems, and all we had available was maybe some old equipment, and of course Linux was free. So we actually built a lot of stuff off this. So this is tried and true tested stuff. So now we look at how all this began. And it all started off with a large American company, AT&T. I say large, I mean massive. And they had specialized software to run their business operations. Back then, it was very rare to find off-the-shelf software. You basically had to have programmers to build this stuff for you, especially if your business model was as different as AT&T. They're a massive telecommunications provider. They have very specific needs, and they need them met. Now, to do this, they built what will become Unix. But they weren't allowed to sell it. They're spending millions and millions of dollars building this thing, and they cannot sell it. I believe it's because they were actually a monopoly holder for the American telecommunication systems, and they were basically banned from competing in other sectors. I think that's part of the agreement and force. So what they came up with was they licensed this whole system to universities, to colleges, to schools for very small amounts of money. Not enough to concern any of the regulators. And this worked out really, really well for them. Basically, it was a win-win solution. AT&T were basically giving out all their software to these universities. So students, professors could all use their software and basically use it for very little cost. Now this was beneficial for the students because they had practical experience on real systems. When they graduate, these guys know how AT&T systems work. That makes them perfect hiring candidates. It also gives them access to how things work. They can see how AT&T do things, why they do it this way. Is there a reason why they picked solution A over solution B? How do these things really, really work? It was a bigger win for AT&T. Again, they actually end up with improved software. Especially if you only have a small group of developers. These people were developing software and pushing it out. But the universities were actually using the software in a much wider context. They weren't just running a billing system or a management system. They were building all sorts of educational networks. And there were problems. And a lot of these students were given these tasks by professors to actually fix these problems. But one of the things they replaced was the file system. It was well known to basically lose files on a very regular basis. Students also developed the job control system in Unix. So a lot of the key features that we take in Unix today came from student work. It came from the community. And what would happen is, all the changes that students made and improved were sent back to AT&T. These changes were incorporated into AT&T's platform, and this was then pushed back out to all the universities. So we basically have people developing their own systems. The Computer Science Research Group, or CSRG, is part of University of California, Berkeley. And they actually set up, the best way forward would be like a clearinghouse for software. And basically what they did was whenever anybody created new software or updated old software for the AT&T system, people would send it to CSRG. And they would build it, they would test it, they would check it. And then they would make that available to anybody else who had an AT&T license. So now things have changed slightly. You have AT&T providing the main platform, but you have hundreds of different universities, thousands of developers working on all these things, improving all these features, and giving back to AT&T. Every improvement that every university made, everybody else got. If you worked out how much you have to spend to pay each individual for all the work they did, this sort of platform would cost many times more than it did. AT&T was basically Latin. They were getting their system developed for free. CSRG was also responsible for working with DARPA, the agency responsible for a lot of the high-tech research and defense and military research for the United States. For example, TCP/IP, which obviously powers the internet, that was originally designed as a command and control system, I believe for nuclear weapons. There was a big problem. If you go back not too far, if you wanted to control certain systems, you had a direct link to those systems. If you were able to take out a particular target, you would break the link to all the other command subsystems. If you knew what you were looking for, you could cause severe problems. TCP was designed to be completely redundant, to work around any potential problems, so that if an entire site or center was lost, the network would still function. And we see this in the internet every day. For example, I think Hong Kong has 2 main fiber interconnections to the rest of the world. If someone puts an axe through that fiber, the internet will go extremely slow, but it'll keep working. And so this sort of technology was developed, and again, that was put into this platform, it was funded, it was made up to everybody. So these new technologies have been designed, developed, pushed out to pretty much everybody who wants them. And this sort of model had never existed before. This brought around to BSD, which is more formally known as the Berkeley Software Distribution. And this basically contained all the software we just talked about that CSRG was managing. And anybody with an AT&T license could download this software and use it. It was very, very efficient. And there are actually some descendants from BSD. Some of you might know. FreeBSD, OpenBSD, NetBSD, PCBSD. They have many years of experience. They're built on a very robust platform. They have some philosophy differences with Linux. Linux tends to pick the best of breed from everywhere and bring it together. BSD does not believe in that. They believe in having the core system developed as a whole and then adding things around it. So there's different philosophies about how the system is developed and how it should work. But in all honesty, it's more similar to Linux than different. Apache on BSD is basically Apache on Linux. It's not a big difference. If you can use one, you can use the other. Now this is a copyright notice from one of the early BSD releases. You'll notice the first date, 1979. That's 32 years ago. Now this particular project, this way of thinking, was basically in full speed long before I was born. But by the time I was old enough to use a computer, this sort of methodology for developing software had gone. It no longer existed. Of course, there was like public domain software, there was freeware, there was little bits and pieces here, but this whole concept of it being normal that you share software had gone. One of the things with BSD is the BSD license. This is pretty much the underpinning of the start of all free software. Basically, these are the three rules that apply. Now, the first rule, which isn't actually written here, so you can call it rule 0, is you can do anything you like with this software. Whatever you want. Build it, sell it, edit it, change it, whatever you want. But you must not claim that you wrote it. You can't say you wrote the software. You can say you modified the software, you can take credit for the work you've done, but you can't claim work for other people's efforts. Second, don't blame us if it breaks. That has happened in lots of different particular projects. If you install an update and it accidentally erases your stored area network and it loses 10 years of research data, tough. That's your problem. There's no warranty implied or otherwise. If it destroys your system, it's tough luck. You didn't pay anything for it, we're not liable. You don't have to use this. And lastly, you cannot use their names to promote your work. So you can't build your own system and then say it's from this foundation or it's backed by these people or it's from this. You can say it's derived from, you can say you made changes to it, but you can't use their name to advertise it. These extracts are taken from a book by Michael Lucas called Absolute FreeBSD. A lot of the history that I briefly covered here is in that book. It's a very, very good book. It's definitely worth a read. I'm sure a lot of you recognize this logo. Does anybody not recognize this logo? This BSD license had great impact. Does anybody remember OS 9? Did anybody like OS 9? No, it sucked. I mean, everybody said it sucked. It was easy to use, but it was nasty. Apple started having a problem. They were competing with things like Windows 2000, Windows XP. These things were fast, they looked nice. OS 9 didn't. But Apple at the time didn't really have the sort of resources that Microsoft now then still commands. So they needed a solution. And basically the solution was absolute genius. They knew that the BSD license meant they could do anything they wanted with the source code. So they took it. OS 10 is Unix. The core of OS 10 is basically FreeBSD. And they've done, now don't get me wrong, Apple have done a lot of work on this, and a lot of that effort is being pushed back to the community. Apple have done good. But the core of OS 10 is Unix. The reason why Mac OS 10 is stable is because they took an operating system that for 30 years is renowned for its reliability, its stability, its security, its flexibility, its open nature. So when they started developing OS 10, they had a complete operating system to build on. They had device drivers, they had file systems, it was all there ready for use. rather than put everything from scratch, all Apple did was focus on the bits they were best at, user interface design. They also controlled the platform, so they were able to tailor the driver specifically for what they were doing. They were able to focus on the bits you're interested in. That's why OS X is nice to look at and why it's so easy to use, because that's where all the money went. All the all the really hard stuff of building device level stuff or developing systems, they've already had that from the BSU project. So the beginning of the end, what really changed things? Basically, AT&T set up a company called Unix System Laboratories, USL, to sell Unix to enterprise and big companies. And at that time, they still maintained a relationship with universities. So it's still universities, professors, students, groups, research functions, contracts, all pumping out all this excellent source code. It's going back to AT&T. Everything's great. And then AT&T was packaging this up and selling it at great cost to businesses. They loved this. They could sell software that was awesome, that they knew how to write. Fantastic. Get something for nothing. It went a bit sour in 1992. The BSD released all the source code to the public. Now, previously, they only released it to people who held AT&T licenses. Now they give it to everyone. AT&T was unimpressed. In fact, they immediately sued the BSD project for breach of intellectual property and copyright. And this battle went on for 2 years. BSD won. When they audited the source code of AT&T Unix, the vast majority was BSD. The actual code belonging to AT&T was only a small fraction of the system. So AT&T had basically been selling BSD for years. Complained when BSD wanted to open up their platform, and then it was made plainly aware that actually what AT&T actually owned and the work they actually did was actually a very small piece. AT&T actually withheld certain key files which they did own copyright for. And they were, of course, the key files that make the system work. So BSD, being experts in operating system design, just replaced them and still released them. But what changed? Why did this change? Why did it go from software for everybody to software for the highest bidder? Basically, it's down to money. Computers became cheap. If you look at when computers were first made available, they filled entire rooms. They cost about $100 million to buy and $10 million a year to maintain. This was big money. But the problem is, how do you sell a $10 million computer to a company? Well, it has to do something for them. It has to give them more value than they're paying for it. And for that, the computer needs software. Giving them a computer system is useless. It doesn't do anything. So people like AT&T and other companies, or computer vendors, sorry, not AT&T, would write software for these machines. If you're running a big bank, they will write you some banking applications. And they basically consider this a cost of sale. They don't really care about the software. The software is just what they need to sell you that machine. And when you're paying $10 million a year, they can afford it. The problem was computers became cheap. Businesses could buy these servers. Not too long after that, mini computers became available. PCs became available. The PC computer became a commodity. Anybody who wanted one within reason could get their hands on one. This changed everything. People weren't buying $10 million computers anymore. And then they realized, well, actually, the real value is now in the software. That's why there was a big legal battle. That's why software and intellectual property is now such a big deal. Because you can buy a computer from Chamswood code for basically nothing. Where's the money? Who's going to make money out of this? Moving on, in 1980, so we're basically stepping 1 year after BSD really started going. Can anybody tell me what that is? No? It's not IBM.
Is that ICL?
No? No. Anybody else? This is actually a Xerox, but Xerox what? not a computer. This is actually the Xerox 9700, released in 1977. This is the world's first commercial laser printer. If you would like one of these awesome pieces of equipment, you need a mortgage. It is extremely expensive. You could spend millions on one of these things. But it was state of the art. And one of the first people to receive this in 1980 was MIT. But they had a problem. Like most places, things aren't set up quite the way you'd like. And at MIT, everybody who used this printer wasn't just in a different room. They were on a different floor. So you print your page. When's it going to be printed? What if the printer's not toner? Well, whatever these things used back then for toner. What if the page is jammed? How would you know? It's like 2 stories up. Now the previous printer, a guy called Richard Stallman, who we'll look at very quickly in a second, he changed the software. They had the source code, and they enhanced it so that if the printer printed a page, or if the page got stuck, it would send you a message. So you immediately knew when you had to go and get this. And that was a feature this printer obviously didn't have. So they contacted her and said, hey, this is a real awesome feature that we really, really need. Please give us the source code so we can add it. And Xerox said, no, it's ours. Now what? So that moves on to this interesting fellow. Richard Stallman is actually dressed as Sidney Lucius, one of his many avatars. His halo is in fact I believe it's a 12-inch platter disc from the 70s. He's widely considered to be the father of the free software movement. And he basically wrote his own from scratch. He is a key proponent of open source, free software. And he believes that all software should be free. It's a social right, it's a social benefit. Commercial software is antisocial and doesn't help society. In fact, it causes problems. So this is a guy who believes everything should be open source. When people started setting up little commercial ventures to try and take over the computer lab, he would write code that would do the same as them for free, so that no one person could ever take control. As soon as they developed a system that they wanted to run on all the machines, you had to pay the license, you had to use their software, you were a free one. So you weren't locked in, you had a choice. And if you wanted to make changes, if it didn't do what you wanted, you could do so. This was the key freedom he wanted to get across. If you want to give it to your neighbor, you should be allowed to do so. If you want to change it to make it work better for you, you should be allowed to do so. These are key rights in the free software movement. He announced what's called the GNU project, or the GNU project in 1983, and he founded in 1984. They are the key behind the free software license, which is similar in ideals to BSD, but it gives a lot more guarantees about what you can and what you can't do. And with the BSD license, you can do anything you want, apart from those 3 things that we mentioned earlier. So Apple doesn't have to give you the source code, because the license doesn't require it. Free software, you do have to contribute back. If you take a piece of free software, you enhance it, you can sell that to someone. But you must also make the source code available. So if they wish to enhance it or they wish to fix things, they may do so. So this is a very social way of doing development. We talk about social networking today. It's a great new technology. It's very, very new. It's not. This goes back many, many years. In this case, back in the 80s. Now this is the new logo. Basically, they didn't like, GNU stands for GNU is not Unix. It's a recursive acronym. And they weren't happy with the current state of affairs, where you just had to use what you were given. And they weren't happy with the way that, well, if we give you the source code and you make changes, it's still ours. You changed our code, it belongs to us. You can fix it, but it's ours. Well, that's hardly fair. And plus, they had all their restrictions to it. So the only way to get around this problem was basically, you write everything that you want from scratch. If you run it from scratch and you release it under a free license, you can do anything you want with it, and you then control it. And this is really what the new project did. They built a vast range of tools. The GCC compiler is probably the biggest well-known solution they provide. But there was a problem. Many commands on Unix are very common. If you ever take a backup, you would probably use the tar command. And then you take your tar command and you compress it. Now, what tar does is basically it gets all your files together, sticks it into one file. That's all it does. You have another command that will take that large file, make it into a small file. But it would never, I can't think of any reason why you would create a tar file and then not compress it. There'd be no point. But that's what you had to do with Unix was. You had to create a tar file, then you had to compress it. To use it, you had to decompress it, then you had to extract it. Well, the GNU toolset supports the compression built in. So if you use GNU tar, you can just say minus Z, and it will decompress it automatically for you. The one in Solaris today, as in if you bought Solaris today and you looked at the tar command, it doesn't support that, or at least it didn't when I last used it. So the GNU tools were enhanced. Why are they enhanced? They were written by the people that used the software. These are people like us. These are people that did these tasks on a daily basis, knew our pain points, knew our problems, and were able to enhance the software to solve them. So the tools are excellent. And loads of people would buy Solaris or Unix and install all the GNU tools and use them because they were just simply better. There was a problem though. It still required Unix. You still had to pay your money to Sun. You still had to pay your money to HP. It wasn't a platform, it was just a set of tools. Until 1991, this is probably one of the most understated emails that you can imagine, but it changed the course of computer history. Basically, it said, hello everybody out there, still using Linux, which was a platform that provided a Unix operating system for basically home PCs, as opposed to big mainframes, which normal people couldn't afford. I'm doing a free operating system. It's just a hobby. It won't be big, and it won't be professional. This was an email sent by Linus Torvalds in 1991 to the Linux mailing group. I've got a hobby. I've just done this cool little thing. I think it might be interesting for people. And he sent it out. This was the missing ingredient that the new group hadn't had. Now they had the kernel. Now they had the actual operating system that their tools could run with. This was the key thing they were looking for. Now you didn't need Unix. You didn't need Solaris. You didn't need HPUX, AIX. You could run this, and it was free. You didn't have to pay anything. So that's the Tux, the Linux mascot, has a huge following. This thing exploded from 1991, where it was just a simple, hey, I've just made this cool little thing. In the case of months, it massively improved. People took this up and added to it. The biggest issue with all these projects is getting started. Once you have that little thing starting off, people added to it. It's open source, and anybody could. And you're talking about thousands of people that have been looking for something just like this, but for whatever reason didn't do it themselves. Now they have to start, everybody started chipping in. People added stuff, and it snowballed. So now, I was bringing to our distros and distributions. Linux is the kernel. It's the bit that makes everything else run. Everything around that is the use spaces, the tools, the applications. There's no such thing as the Linux distribution. There's no one Linux. There's only distributions, and these were built by people to solve their needs. It wasn't built by a large company telling us, hey, well, this is the right way to do computing. These are built by individuals looking for something to solve their problems. I don't know if anyone recognizes any of these logos. No? Yeah. Now these are an example of Linux distributions. Each one is very, very different, but they're all Linux. If you know one platform, you can use any of them in this list. You might not like it, you might not like the way it does things, but they're basically the same platform. If you start from the top left, Fedora, and we'll look at that a bit more, but that's your general purpose, user-oriented distribution. You install it, it works. Debian, which is the second one in the curly thing. Debian takes a different approach. They believe stability is the key. That's why if you look at a Debian system, you tend to find that the versions of software are far behind what you'll see in Fedora or Ubuntu. Because Debian prefers stability. They will wait months, sometimes even years, before making an upgrade, because what they have now is secure and it works. They don't like taking risks. So if you're the sort of person who wants a free operating system that's stable and isn't going to take risks, then maybe Debian is for you. Gentoo, the next one across, everything is built from source. It's very much like BSD. So when you download packages, you download the source code, it compiles everything for you. This means everything you build on that machine is customized specifically for your needs. You build it on your machine, it looks at the architecture. If you have an Intel Core 2 Duo processor, it will build it specifically to take advantage of that processor. Now, systems like Fedora and Debian can't do that. They have to assume the lowest common denominator. Most systems, that's an i686 or a Pentium class machine. In older distributions, it's a 386. When it's built for a 386, it will run on your brand new Core 2 Duo, your i7, but it's not going to take advantage of all the new features you have. It's built to run on i386. Now, Gentoo doesn't have this problem because it builds for exactly what you have. If you have, for example, if you install a web server on Gentoo, it will only install the web server. If you tell it, I want everything to do with PHP, it will then rebuild all your software to include PHP. But it only builds the minimum that it has to build. That's why Gentoo is known as a very, very fast operating system. There's no cruft. It only installs what you want. It customizes it for your exact platform. Lots of benefits to that. But it means you have to be comfortable building packages, installing things. Not everybody is. So that might not be for you. Arch Linux in the middle takes it even further than Gentoo. There, everything is built by hand. All the nice, from a Gentoo point of view, you don't need to really know what you're doing to build the packages. It's all hidden behind a nice interface. Arch Linux, you really need to know what you're doing. Some people want that, so it's available. Ubuntu is designed to be the platform everybody just wants to put in the disk and have everything working. You want your web browser, you want Flash, you want Wi-Fi to work out of the box. You plug in a scanner, you plug in a printer, it just works. Ubuntu can give you that. And then you have, for example, Red Hat and CentOS for the enterprise operating systems. Basically, what I'm trying to get across here is each Linux is different. There's not one Linux for everybody. It depends what you personally want out of a platform. And of course, we're looking at mostly enterprise Linux, which is a platform that you install, you get support from, and it's stable. But that might be for your servers. For your laptops, you might want Ubuntu. Or you might want to, or if you're building, for example, a system that needs to be ultra low latency, if you're doing stock trading, you need to tweak very, very specific settings. You might want Gentoo or Arch Linux because that gives you more control. So you can pick whichever one suits your needs. These are all free. They're all available to you. If you don't like any of these, you can make your own. There's no restriction. Okay, so now we're actually going to get to enterprise Linux. So as a quick recap on BSD, it was very much share and share alike. It was community driven. There's a large open spirit. They call it the hacker culture. Everybody helped everybody else. Everybody got their hands dirty. Computers then weren't commoditized today. They were big, expensive machines. It was exciting times. They were there pushing forward the frontiers of science. And the key thing was, it was cooperative more than competitive. People were helping people. It wasn't me versus you. It was us versus basically the universe. This is Red Hat. This is actually called the Shadow map. Not really sure why, but it's a pretty cool logo. It was a very popular distribution, and over the course of the early 90s to late 90s, it gained a very large following, including myself. And basically, Red Hat took the source code from a random environment, built it together, and put it in a box for you. So you could go to a computer shop, you could buy this, put the CDs in, work your way through the install, and you have a Linux box. Previous to distributions like Red Hat, you had to download and build it yourself. You could, but Red Hat took a lot of the pain out of this for you. But as Red Hat became more advanced and more people started using it, they realized they had a problem, and it was a very, very, very big problem. And that was their customer base split. They had two types of customer, complete opposites. Whatever you would do to make customer one happy would really upset customer two. They wanted very different things. So this was a big problem. Now, basically you had enthusiasts and you had the enterprise environment. So for the enthusiasts, can I recognize this guy? No prices for guessing who might come up next on the other side. Basically, this sort of person wanted the latest and greatest. I want updates as fast as possible. I want, when they release a new version of software, I want it immediately. I want to be able to buy a graphics card. I want it to work. I don't want to wait 10 years to be able to use it. I want everything. I want it now. I want it better. I want it faster. Okay, fair enough. We can do that. Unfortunately, there's another type of customer. They wanted something else. This guy wants stability. He wants to run his business on this. That's hard to do. Red Hat was releasing quite often, every 6 months to a year, 18 months. If you're an enthusiast, that is a long time to wait. If you're a business, this is going to make you cry. Every 6 months, you have to update your systems, check that your software works on all the new versions. What if it doesn't? What if you upgrade your system, you deploy your software, and it doesn't work on the new version? Or what are you going to do then? And this really was a big problem. So they tried offering me, this is actually Red Hat Linux, it was their core offering. This was around until Red Hat 9. And what they tried doing was offering this with enhanced support. So you get Red Hat 6.2 and Red Hat 6.2e, and it would be the enterprise supported version. The idea was you could get support, you could phone people, you could get help, and if you didn't want to pay for that, you just have the other version. And again, this version was still available for free. It didn't work. People liked it, but it didn't solve the underlying problem. The platform was changing. Even if Red Hat supported you, you still have to go through a lot of effort to make these changes. This was a huge problem. And for a big business, it cost millions. It put a lot of people off using Linux. So they couldn't take this into account. So Red Hat then split again to another platform. The short version is pronounced RHEL. As far as I know, that's not actually an official designation. Everybody uses it. Every Red Hat calls it RHEL. Even though the company doesn't acknowledge it as an official term, everybody calls it that. Sorry. Red Hat Enterprise Linux was fully supported with commercial backing. Fully supported. This gave you the benefits that the enterprise customers were looking for. And now they have another problem. The enthusiasts. And for this, they set up a completely separate project that they provided backing for called Fedora Core. This actually worked very well. Fedora Core became the test bed for RHEL. So something we called it Fedora tested, tried by the enthusiast community. When it was ready, Red Hat would take that and put it into the enterprise version. Fedora Core matured quite quickly, I think only a few years, and dropped the core. And it's now known only as Fedora. So let's actually look at what enterprise Linux really is. Now we can see why it was created. We had customers who didn't just want to pick up the phone. We had customers who needed a system to stay the same for a long period of time. If you're a bank, you can't be changing your backend service every year. It's just not feasible. So that's what enterprise Linux was supposed to correct. Now the main thing really is the long-term support. In the case of Red Hat and CentOS, this is 7 years. So they guarantee that for 7 years, your platform will receive updates. Every 6 months or so, they'll release a minor revision, which includes new hardware, speed enhancements, minor bug fixes. Security updates are immediately released. So you have a platform that's going to stay the same, it's going to receive instant security updates, and you can get regular enhancements every 6 months that you can, on a fixed schedule that you can plan for. This was one of the, and in my opinion, one of the most important the software talks to other software. If you buy a very expensive piece of software that depends on a web server, it will be built against a particular web server, say 1.0. Now, if you actually upgrade to a new platform and it installs 1.5, it's going to break your application. What do you do? Well, the company who provides the application will say, oh, we don't support 1.5, it must be 1.0. Well, I can't have that necessarily on the old platform. They don't care. So, one of the key things that Red Hat Enterprise offers, they will take security fixes from the latest versions and they will implement them in the original version that's installed on your machine. The version numbers in RHEL do not change. Any software built that runs on day 0, so if you buy Red Hat Enterprise Linux 6 today, have an application running on an Oracle or a custom application, in 7 years when that's retired, the same application will keep on working. This gives you great stability. It also gives you, you know you're going to be safe. You know you don't have to worry about upgrading your machine. This takes a lot of worry out of people. A lot of people wanted to use Linux because it was cheaper. But how cheap is it really when it keeps breaking applications every time it's been upgraded? I actually used to run a production DNS server around the internet by lookups for all my websites. And I was actually running Gen 2. I did a standard upgrade. Download the latest updates and apply them. One of these updates updated my DNS server from version 8 to a completely new version, number 9, and then killed my DNS system. It removed the config files were not compatible with the new version. They weren't in the same place, and it had actually deleted my config files. Now that's my own fault. I really wasn't paying attention. But had I been running Enterprise Linux, it wouldn't have mattered. All the upgrades would have just kept on working. They wouldn't have changed anything. It would be fine. We touched on this briefly. Bug fixes and enhancements, they come out regularly every 6 months. And another key feature for a lot of people is Red Hat Enterprise Linux as a platform is certified. So from a software point of view, Oracle is certified to run on Enterprise on RHEL. I believe SAP is also certified to run on RHEL. There's a whole range of applications that have been tested by the vendors to run on RHEL. So you know if you want to run Oracle, Red Hat is a partner, it's fully certified, you can do that. You don't have to worry about calling Oracle and saying, hey, I got this problem. Oh, what platform? Oh, I'm using Enterprise Linux. We don't support it. So you know that you're on safe ground. Same is true for hardware. Red Hat partners with Dell, with IBM, with Fujitsu, with HP. All their platforms are put through rigorous hardware testing and certified for each platform Red Hat provides. So you can go onto Red Hat's website and see all the hardware that's fully supported. So you can make sure that the hardware you buy is going to work. And you can make sure the software you want to get will run on the platform. Now these are guarantees that normal Linux cannot give you. Red Hat spends a lot of money and a lot of effort working with all these different partners to give you a solution that actually ties everything together. Now obviously this isn't just Red Hat. Novell does the same thing for SUSE, Canonical does the same thing for Ubuntu. But it's very different from the free version we looked at earlier where you downloaded it and you hope for the best. These are becoming very serious pieces of equipment. And they're also certified for certain environments, for example, for use in government, for use in the military, for use in the health sector, for use in places where, things like air traffic control, where certain requirements are necessary in the system. So, Enterprise Linux includes RHEL, which looked at, Red Hat Enterprise Linux, SLES, SUSE Linux Enterprise Server, that's Novell's offering. Ubuntu is Cananical's offering, the LTS, the long-term support. And CentOS, the Community Enterprise Operating System. It doesn't include any of these. These are basically ones we included on our distribution list earlier. None of these offer the guarantees I've just told you about. They may work just fine, but they're not the same. There's no guarantee. Basically, these are developed at the speed of their community. It's whatever the community wants to do. If the community wants to push you in a direction, that's the way the community is going to go. You don't really have much say or control in it. Basically, if you don't like where Fedora is going, you go to Ubuntu, or you go somewhere else. You just go this own way. You have to take your pick. You can use these in production. Lots of companies do, especially if they need latency-based features or they need something very specific. And in those cases, they normally have trained professionals to run it for them. You can use these in production, certainly, but for a lot of places it's just not suitable. Okay, this is actually from the Red Hat development model for Red Hat Enterprise Linux. Basically, unfortunately it hasn't come out very clearly, but this is basically the worldwide community. These are the open source projects like Apache, SendMail, all the projects that actually make up Linux. And remember, Linux is just a collection of all these different applications put into one place for you. That's what a distribution is, the Linux core and various applications. So this is where all those applications lie. And what the Fedora project does, and the Fedora community, again, these are all volunteers, they take projects from the community and put them into Fedora. So they go through development, they go through engineering, they do test releases, integration testing, packaging, and then it becomes part of Fedora. This cycle is ongoing. Whenever Fedora makes an improvement, it goes back into the community. It doesn't stay in Fedora, they don't keep it to themselves, it's shared and shared alike. So every change Fedora makes, there are benefits. Now what Red Hat does is it's like almost exactly the same cycle. But it doesn't take from the community, it takes from Fedora. So basically all the new features go to Fedora, where they're tested by enthusiasts for up to 2, maybe 3 years, or however long it takes. So Red Hat can see they're stable, they work, and they're safe. When they're happy that it's safe, they put it into the Red Hat production cycle. So if there's any problems found in Red Hat Enterprise Linux, they make a fix, it goes back to the community, filters back into Fedora, and ultimately filters back into Red Hat. This is a continuous cycle of development. So that's part of the Fedora project. This is the consumer grade version. It has a very fast release cycle. New versions of Fedora arrive every 6 months. And they're usually very, very different. For example, on my laptop, Fedora 10 worked beautifully. Fedora 11, no. The browser doesn't work properly, Wi-Fi is a lot more, it disconnects all the time. But Fedora 13 might be fine. Then Fedora 14 might break it again. I'm not no guarantees. It's a fast release cycle, latest and greatest everything, but you get what you get. They release betas every 3 months. So basically after 4 releases made, 3 months later you get beta 1, next one beta 2, then beta 3, then release, and it repeats constantly. They only support for 2 years. That means in the best case scenario, you install your server, after 2 years you must replace it. It's your best case scenario. That, depending on what you're using it for, that may be acceptable for most businesses, and unfortunately it's not. And Fedora is often years ahead of RHEL. RHEL 6 only just been released. Prior to that, RHEL 5 was released, I believe 4 or so years ago. I think maybe more than that. So you'll be stuck using versions of software in RHEL that are years behind Fedora. But that comes at a price. Red Hat, on the other hand, is the opposite of Fedora. It doesn't release very often. But the payoff is it's very stable. There's very few changes to the platform. There is a downside of using Red Hat Enterprise Linux, and that is basically you have to pay for it. And it's really not cheap. A basic server license for a year per server is about $2,500 US. For a large, for a banking corporation, it's not a big deal. And in fairness, the support you get from Red Hat is excellent. But if you're someone like me, or you simply go on a server, you cannot possibly afford this. It's just too expensive. But there is a reason why they charge this fund, and almost all the money from this goes into paying for developers. Red Hat employs developers from all the key open source projects, and they work on those projects. That's pretty much their day job. Their day job is to work on their hobby. Red Hat benefits because they get improved versions. The project benefits because they get more time spent developing. Everybody wins. So it's not as if Red Hat is basically taking everybody's work, selling it, keeping all the money. That money, that effort is going back to the community. Everybody wins. So Red Hat is free, but it's free as in speech. The source code for Red Hat is available to anybody who has a license, as per the software agreement, the open source agreement. So if you have a license for Enterprise Linux 6, or Enterprise Linux 4, you can download any of the source code and you can do anything you want with it. You can't buy a trademark, so you can't sell logos. Anything else is fine. Again, in accordance with license. That brings us on to this, CentOS, the Community Enterprise Operating System, my personal favorite. It's the simplistic distinction between CentOS and RHEL is this one is free as in beer. This one costs you nothing, you can download it for free. The relationship is a lot more intricate than that, however. And it's basically a symbiosis. People who tend to use, CentOS cannot exist without Red Hat. CentOS is just a rebuild of the stuff that Red Hat releases. Red Hat releases it, CentOS takes it, repackages it, releases it. And that cycle continues. So without Red Hat, CentOS cannot exist. And most people think, well, okay, well, surely Red Hat isn't depressed about this. They're doing all this effort, they're spending all this money, you'll get it for free. Well, that's not actually the case. CentOS actually provides a very different solution for people like us. So say we want to have an enterprise-level operating system, but we don't need support. I don't need Linux support. I'm the sort of person that Red Hat can send out to help you. So I really don't benefit from paying support. But if I was running this for a small business, and that business became larger, became multinational, depended on these things, if I was doing consultancy for a bank or a stock exchange, I wouldn't tell them to use CentOS. This is a mission-critical system. You want support on it. You want to be able to pick up the phone and say, it's broken, send me someone to fix it. You need that sort of interaction. So what they've actually found is, there's millions of people using CentOS. When their needs become more advanced, when they need support, when they need to build more intensive environments, they need help, they upgrade to Red Hat. It's very rare for someone to run CentOS and then upgrade, say, Ubuntu or Sudo. So this works really well. Red Hat gets customers from CentOS. CentOS provides a platform for people who cannot afford or do not require the support of Red Hat offers. It's a nice cycle. Again, everybody wins. So just to summarize that, open source has a long history. It's not new. It may not be called open source at the beginning, but this concept of share and share alike has been around for decades. And basically, the main difference between enterprise Linux and other forms of Linux is it's supportable, it's stable, it's robust, excuse me, and you can depend on it. I did mention on the website that there was going to be a raffle for some free ebooks and for some physical books, but they're still in the post. They haven't turned up for the States yet. I'm still waiting on those from Apress. So this will still happen, it will just be when they actually arrive. So make sure you sign your name on the form, because that's where I'll be taking names from. So if you haven't signed the attendance form, please make sure that you do. Okay, as promised, you listened to me for almost precisely